Right. Yeah. Okay. So, Pete, the way we've done this in the past is kind of a extended interview style, then followed by Q&A from the
Perfect.
audience. So, yeah. Okay. But first, I'm going to start and then give my intro to Pete. But I'll try and keep it brief. But what Allison alluded to is really what was top of mind as I was preparing for this call today, which is that when the history of of space activities in the early 21st century is chronicled, which I guess it's starting to be, but I mean, when it's written, as they say, Pete Warden will be a central figure, if not the central figure. Much of what we think of as, new space and related things is really, Pete engineered it, and pulled the strings. SpaceX, Planet Labs, um, all kinds of different missions, not just in the 21st century, but starting slightly before, I believe, because like me, Pete has been around a long time. In fact, Pete has been around such a long time that he is mentor, tutor, advisor, and inspiration and leader for me, who I have learned so much from. And uh, and and I'm being pinged by people who are having link problems. Sorry. And um, we're going to uh, start maybe with a bit of history. I mean, he's not just a leader and mentor to literally hundreds of younger people and friend. He is a military leader, air general in the Air Force. He's a mission leader of many space missions. He was a NASA center director for many years. That's how I got to know him. Uh, he's a professor of astrophysics, and now he's the director of an organization, which is super exciting, which we'll get into talking about later. So I don't know, Pete, do you want to maybe start with something personal, like how did you get interested in these topics of let's say space and all the related science and politics things? Can you talk a little bit about what drew you into this world as a younger man?
Well, sure. I don't know if my connection is good, but hopefully it is. But uh, uh, I was born on the 21st of October, 1949. So I was for the first half of the 20th century. And it turns out I didn't realize this until recently. That's a significant date. It turned out it's the anniversary of the Battle of Trafalgar. It's also I was born the same day, the same year as Bibi Netanyahu. So I guess it's propitious or maybe impropitious. But at any rate, when I first started to learn to read, this was 1955 or so. My mother gave me two little books, and these might have been prophetic, but one of them was called Planets, and the other was called Stars. They're little kids' books with pictures of planets and stars. And I sort of looked, that really inspired me to learn to read the alphabet because the pictures were really neat, but I wanted to see what the words were. And at the end of this, I sort of said to my mother, I said, the planets are kind of boring. And, there doesn't seem to be any interesting aliens or, anything but the stars. That there was a little picture in the end of aliens in some nearby star system. And I said, well, this is what I wanted to do. And so I'd ask what, people that want to study stars, what do they do? And she said, well, they're astronomers. And so I was about 6, 7 years old when I told everybody I was going to be an astronomer. And of course, then was in high school and college in the 60s during the Apollo program and very big excitement. And so I ended up looking for universities that had astronomy programs. And fortunately, being a Michigan resident, there was the University of Michigan, which, in addition to having the best football team in the universe, has also got a really good astronomy department. And so I ended up going there and majoring in astronomy. But
Did you play football? Did you play football?
no. Yeah, although the football team lived in my dormitory.
Oh, great.
And I was later involved in student politics, and I didn't always get along with him. There was a very famous football player who ended up being a big TV star, Dan Deerdorf. And I was having some political argument with him, and he won it because he just picked me up, put me over his head, and swirled me around. And I said, "Okay, you're right." So sometimes, intellect is defeated by brute force. That was another lesson I learned. But at any rate, there was 120 people that were going to major in astronomy when I was, the first couple of years I was there, and that was until they discovered you need to understand calculus and a few other things. So ended up 6 of us got degrees in astronomy. 2 of us went to graduate school, and I think I'm the only one still doing astronomy. So it was kind of a big narrowing down. But ever since I was a little kid, I really wanted to visit the nearby stars. And I remember when I graduated from college at the University of Michigan, some local newspaper did a little interview. It was it says this kid just graduated from Michigan. He's going to join the Air Force. The and so one of the things they said, he thinks we're going to go send missions to the stars in the next, you know, in his lifetime. And I remember my father, who just died a couple years ago. He was almost 100. I don't know, about 6 or 8 years ago, he had the little clipping from the local newspaper, and he gave it to me, and it says, "At least you're consistent."
Mhm.
That
Oh,
you know,
okay. You are consistent, and we're going to rewind later and come back to more of your unfolding career. But speaking of going to the nearby stars, perhaps you could speak a little bit about your Zoom background and how that relates to what you're currently doing.
sure. I mean, I kept pushing in NASA, and prior to that in the Air Force, that, we should looking at interstellar probes. And while I was the director at NASA Ames, where I met Creon and a number of other really cool people.
Some of who are on this call, like John
Yep,
Park.
many of them were on the call. Yes, and the I was trying to push to do interstellar stuff, and of course NASA, which is a great organization, but sometimes is a little short sighted. And uh, so one evening, I was in Washington D.C., and a good friend of mine ran the tactical technology office at DARPA, Dave Nyland. And so you'll find that with me, a lot of things, cool things, are done with a bit of drink. In fact, I'm just having a little champagne here now. Uh, I'm in Europe, but the Dave and I had a couple beers, and he said, "Don't you think it's time we start doing something about going interstellar?" And I said, "Sure." And he said, "Look, I'm an office director at DARPA. I can put $1 million in." I said, "Well, NASA's not nearly as rich, but I can probably put in 100,000, but I can put in a lot of really cool people," and which we did. So we set up something called the 100-Year Starship Project.
Yeah, I remember I was heavily involved in that very first gathering at Cavallo, and yeah, okay, keep going.
Well, we had a couple meetings that culminated in a meeting in Orlando, Florida. But the uh, uh, the uh, the idea, we were going to have a lot of people come and talk about how do we get to the stars. A lot of it had to do more with policy and funding, but also technology. And it turned out that I probably talked out of turn at a meeting held by the Long Now Foundation. So there was a comment that I made sort of offhand that went viral, and viral a long way. And it got it all goofed up. It said, well, there was this new 100-year Starship program that said we're going to go to Mars in 100 years, which was all rubbish. But anyhow, it got far too much attention. So the first thing I know, I got a nasty call from the NASA administrator, who said, I'm the administrator, not you. Or what's this baloney? And
The NASA administrator, which one, Mike or
Charlie Boulder.
Charlie? Okay.
Charlie's a good guy, but he was called by various members of Congress, or, "Why are you wasting money on this? We don't have enough money for the Space Launch System." And this was one of these phone calls where Charlie was a retired 2-star general, and I was a 1-star general. Whenever one general calls another general, that means it's not good. And so that was one of the few times I knew Charlie to get really excited. So he said, "Look, you can go ahead and continue this thing, but I want the NASA logo off it." Okay. Well, a few weeks later, apparently the Deputy Secretary of Defense had a similar discussion with DARPA. And so there was a DARPA logo went off it. And in the end, Dave Nyland, his career was shortened a little bit by this issue. But we had a meeting in the end with 1,000 people in Orlando, Florida, sponsored by no one officially. And but out of that came a lot of really interesting stuff. Uh, and the key conclusion was the private sector needed to do this. And about the same time all this happened, uh, I was approached by Vanity Fair, and my chief of staff came in and asked me, "You'll never guess who's out here to see you." I uh, said, "No, I probably won't." And this Karen Bradford just retired a couple of weeks ago, and she said, "Well, it's Vanity Fair," and I said, "Well, am I the best dressed center director?" She says, "No, you're kind of near the bottom." But it turns out Vanity Fair uh, has the coolest party in Hollywood. It's the post-Oscar party. And a number of these billionaires had been to that. And these billionaires, a few years before, had started the Breakthrough Prize, and which was, the largest prize in science. It's $3 million. There's about 6 or 7 of them given out each year, sponsored by, Mark Zuckerberg, Sergey Brin, Ann Wojcicki, and the founder of it is Yuri Milner, an Israeli investor. And it turned out that they decided to do this prize ceremony at, they wanted to do it at NASA Ames because we have these really cool big airship hangars there when I was there. And so we ended up having a party, but of course, they always tell you if you're going to have a big party, you always invite the landlord. And so they did. And so I got to know these folks pretty well. And Yuri Milner is a physicist by background, and I invited him over to Ames to see the Kepler mission. And my idea was we wanted him to fund a small spacecraft. And I'll get to this picture in a minute because that was a key thing about the target. And to see if we could find planets around the nearest star system, the Alpha Centauri system. He said the that he was willing to fund it, but then when he got back in his car, he said, "But I also want to fund your 100-year starship." And so over the next couple of years, we discussed what to do. I left NASA in 2015 largely to go run this program, and so we've done a couple of things about life in the universe. But the coolest thing, in my opinion, was in 2016 we announced Breakthrough Starshot, which was an effort to send a probe to the nearest star system, the Alpha Centauri system. And Stephen Hawking was with our chief scientific advisor. So this was announced at the New World Trade Center in New York on the 12th of April 2016, which was the anniversary of Yuri Gagarin's flight, who Yuri Milner was named after, by the way, in 1961. And so we've been looking at that as well as looking at the potential of finding intelligent signal. About 2 years ago, our Breakthrough Listen program, which is headquartered at the University of California, Berkeley, the PI there, Professor Andrew Simeon, called me and said, "I think we have a signal." And the signal appeared to come from not Alpha Centauri, but the third star in the system, Proxima Centauri, which we had known a few years before has a planet, indirect means detected, that's Earth-size in the habitable zone.
So hang on, sorry, let me interrupt for a moment, Pete.
But this is an artist's conception of what Proxima Centauri or Proxima b looks like, orbiting Proxima Centauri.
And it's a double star?
Well, it's a triple star. Proxima Centauri is a red dwarf star. It's about a tenth the mass of the sun. It's maybe a 10,000th the luminosity. It orbits around the other two stars, tens of thousands of years. They're pretty distant, but you can see them in the sky there. They'd be pretty bright, and they're a double star. So there's 3 stars in the system.
Right. Got it. Okay. And this is an artist.
This is our target.
Yeah. And so, but for one back up here, you say, we think we have a signal. Could you elaborate on that?
Well, we have a number of programs. The 3 major ones are Breakthrough Starshot, and we send a probe to Alpha Centauri. The second one is breakthrough listen. Can we find a technosignature, evidence of an alien civilization, called breakthrough listen? The third one is, can we actually find a life-bearing planet in the system, called breakthrough watch? And all of them have been pretty successful. Interestingly enough, the breakthrough watch is trying to directly image a planet in that system. We did have a tentative detection of a giant planet orbiting the biggest star in the system, Alpha Centauri A, which, by the way, is pretty interesting because the giant planet was in the habitable zone. And those of you who are science fiction geeks like I am, might remember that Alpha Centauri A in the movie Avatar has a giant planet orbiting it that has moons, one of which is not only habitable, it's inhabited, the Pandora. So it's all very exciting. And, I'm convinced that this system is a fascinating system. It seems to be more complex and interesting than the boring solar system we live in. And it's nearby. It's only 4.3 light years away.
So why don't you just say a little bit more then about the breakthrough programs, and particularly the starshot, which I think might be the dearest to your heart. But whatever you want to chip on the breakthrough programs, maybe elaborate, please.
So the Breakthrough Prize Foundation is funded to recognize science. It's the biggest prizes in science, and we're not really competing with the Nobel Prize, but we are. So to try to really emphasize the role of scientists. So it has a number of sponsors, but the breakthrough initiatives were started in 2015 by Yuri Milner to specifically focus on the big question of life in the universe. So we have missions to say, can we detect life in the universe by emanations that they may do? If there was a technical civilization, a technosignature, it's called. And so Yuri committed 100 million to that. The second major program is breakthrough starshot, which is, can we send a probe there later this century to actually check up close to the Alpha Centauri system. And the third one is breakthrough watch, is can we find a life-bearing planet either in the Alpha Centauri system or some other nearby star system, or potentially find life in our own solar system. So we have a number of programs there that are still in discussion. There's a couple of really major ones I'm not at liberty to talk about yet, but we have big efforts in all three of those.
Fantastic. And just for completeness sake, the Breakthrough Foundation also is active in other fields as well, some of which are near and dear to Foresight people, such as biology, biomedicine, correct? And maybe say a little bit more about the other activities of Breakthrough.
Well, they're not really part of the breakthrough initiatives. Mr. Milner funds a number of efforts, including fundamental biology. One of the big questions he has is how the brain works, and a lot of extra efforts. He's also invested in some foundations looking at life extension and so forth. But the breakthrough initiatives are strictly focused on life in the universe.
Right, but the Breakthrough Prize offers prizes in biology.
Oh yeah,
all kinds of things.
The Breakthrough Prize has three major prizes. There's one in fundamental physics. There's one in mathematics, and there are a number, 4 or 5 typically, in life sciences. And those deal with usually cancer research, genetics, genetic diseases, brain function, and so forth. In addition, we have early career prizes, which are, by the way, the breakthrough prizes are $3 million each. And
they're annual, right?
Yeah, they're given out annually. There's 6 or 7 every year. The last couple of years, due to COVID and now due to world political situation, we're not having an in-person meeting. Hopefully in a year or so, we'll be able to restart that. But we are doing, we have an early career prize called the New Horizons prizes, which are that's $100,000, and those are given to early career people within 10 years of their PhD in physics and mathematics. In addition, we have a very exciting prize. I actually chair the selection committee for high school students. It's called the Breakthrough Junior Challenge. It's a we ask young people around the world to do a couple-minute video on some principle of physics, mathematics, or life sciences. The winner gets it comes to the breakthrough prize ceremony when we have them, and but more important, the winner gets a $250,000 scholarship wherever they want to go. The school gets a $150,000 laboratory. It's equipped with our funds. And maybe the most interesting thing to me, that the teacher that inspired the student gets a $50,000 check, which I think it's really important to identify the mentors and who inspired these young people.
Okay, well, let's see now. Maybe we could change the topic briefly and rewind. Well, no, actually, I want to say one thing before we move on to some other space topics. Uh, what Pete was talking about with the one he's most excited about the high school students, I just have to say that um, when I first met Pete, he brought with it was when he came to NASA Ames as the new center director, and I had been there for like 20 plus years, and I was like, this is an interesting person. That's a whole other topic of why I thought he was so interesting. What I came to know that he was even more interesting than I had initially suspected. But what I noticed was that he brought with him a whole entourage, if you will. I don't know how many people it was, 20, something like that. And many of them were, some of his senior colleagues that he'd collected in his work at the Air Force and academics. But also he brought a whole posse of young folks, like in their 20s. And I uh, made friends with them and everything. But and they later went on to found space companies and have great careers. Of course, now they're like in their 40s. But but what I asked Pete, I was kind of perplexed at this because NASA was a somewhat graying organization, largely by that time. And I asked Pete, why do you have all these young people? And one of the first things that he said to me when I asked him a serious question, because I was just getting to know him, has stuck with me to this day. And I actually wrote it down in this long list of Pete Warden quotes. And I don't think he knows about this list. I mean, it's really public consumption because some of them are like, you could seriously get canceled. But let's just say someday when we're all in person and the recordings are not happening, we will go over some of the quotes. Uh, but be that as it may, what he said, I said, why all these young people? What are you doing with them? And what he said to me was, Priyan, your most important job is to train your replacements. And not that anyone could ever replace Pete, but uh, this is the thing about Pete. He is absolutely dedicated to the next generations. And I guess, like me, you don't have any biological children of your own that you know of. And so you adopt the children of the world, particularly the intelligent ones who are oriented in certain directions that we share interests in, like space and science. And I got to say, I'm going to land this plane shortly, but he is dedicated to this. I saw him not just mentor, but open career doors and funding opportunities and open minds of literally hundreds of young people that he brought to NASA. And this is a thing that is just so unique and inspirational. I know of no one else who's done this. So thank you, Pete. I was too old to get on that train, but well, I got on it anyway. Let's just say by pretending to be young. So maybe we can rewind now. Oh, I want to say one more thing about Pete, and then we'll start. I'll do the questions, and maybe then we'll end and switch over to the audience because, oh, look, we're half past the hour almost. Okay, so, um, Pete, in addition, and then part and parcel as to sort of, I think, meta organizational principle of mentoring all these young people and opening doors for them. Uh, he is another thing that I noticed that was very unique about him, because even back then, long before starshot and all this stuff, he was moving the chess pieces on the board with like literally 1,000-year plan for the future of humanity. Am I correct in that, Pete?
At least.
Okay. And again, that's a unique thing that almost no one people talk about it, the Long Now Foundation and stuff like this, but he was actually doing it, using his influence and his vision and his networks to set things in motion that may not come to pass, for generations. But rewinding now back to a little bit more down to earth, if you will, although it's still space oriented. Maybe you would talk about a few of your favorite missions that you either masterminded or at least shepherded during your career. And I could name some of them that I know of, but why don't you just take off and give a summary of a couple of these exciting space missions that you were instrumental or critical to their actualization?
Well, thank you, Creon, for the kind remarks about mentoring. I mean, I do think it's important to replace yourself, but also replace yourself with somebody better than you, which I think I've done. And but it's a long string of mentors and mentees. I mean, to me, I had 3 or 4 really critical ones. I'll just mention a couple key ones. One was Edward Teller, and another one was Hans Mark, who was the 3rd director of NASA Ames, later became the Secretary of the Air Force and the Chancellor of the University of Texas System and Deputy NASA Administrator. But probably the most influential one to me is Arthur C. Clarke, who I had the privilege of getting to meet about 20 years ago. But I think that's really very important. But missions are important to do stuff. I've been involved in quite a few. Probably the first space mission that I can talk about was I was at the White House, National Space Council, in the 89 and 91, and we had gotten, everybody said, look, all we needed was the president to say, let's go back to the moon and on to Mars. And so the staff got George Bush Sr. to make an announcement on the 20th anniversary of Apollo in 1989 that they were going to go back to the moon and on to Mars. And we said, okay, we're on our way. But it turned out it wasn't to be. You learn a lot about politics working at the White House. And there were a lot of things that stopped that, being one of which was the bureaucracy at NASA, which I wrote a paper later called I referred to NASA as a self-looking ice cream cone. And that's not a comment about the people; it's about the process.
Right, and for that infraction, they made you a center director, so that you had to.
Yeah, that's right. Well, I was in the running to be the NASA administrator, but they picked one of my best friends, Mike Griffin, and so I wanted him to give me a contract, to be on the advisory board. But instead, he said, "I want you to stop complaining and come and help fix it." But anyhow, the mission we did, after I left the White House, I spent a couple of years as the head of technology at the Missile Defense Program, the so-called Star Wars program. And I and some others said, look, we really wanted to do space exploration. And there was an anti-ballistic missile treaty in force then. And, that was a different question, a political question, but it turned out the anti-ballistic missile treaty said that you couldn't test things in a missile defense mode, but we figured out, and the lawyers kind of agreed with us, that, well, that didn't stop us from testing it in non-missile defense mode. So we figured we'd send a probe to the moon, and because there weren't any missiles there, that it would, we'd get away with that, and it would test a lot of the Missile Defense Center sensors and methods. That was called Clementine, and it was launched in.
Why was it called Clementine?
Well, because we didn't like the NASA approach of naming things after some dead Greek or Roman god, or non-existent Greek or Roman god. So we figured, let's name it a good American name. And so we, the old song, oh my darling Clementine, lost and gone, or now you forever. Forever. We thought that was an appropriate thing because we were going to go on and intercept an asteroid. So that was a cool mission. We mapped for the first time in multiple colors the entire moon. And
intercept an asteroid, which is kind of like intercepting a missile.
Yes, it turned out the range rates were almost identical, but it wasn't an anti-ballistic missile mode. So So we did that, and I got fired for it, but that's all right. It wasn't the first time or the last time.
They were
But
going to hire you for some reason, and they finally
yeah,
found. Yeah.
so I went back to. In the end, I ended up going to Ames, as mentioned in uh, 2006, and we had a couple of really cool things ongoing. One that had just been approved was the L-Cross program, which was I wasn't there when they defined the mission, but the idea was to impact the poles of the moon, to blow some material up, see if there's water there. And Clementine had some preliminary evidence there was water in the poles of the moon. And this was a really cool mission, although I learned about being careful about Twitter comments, because I was at the Kennedy Space Center when they were doing the launch. And for the first time, I got to sit at what I called the adult table. They have a final readiness review. Everybody's wearing, suits, and which is in the middle of summer, and it was hotter than Dickens. So they give you a briefing, and they go around the table and say, all right, launch vehicle is go, upper stages go, range is go, weather is go. And the primary payload was the Lunar Reconnaissance Orbiter that was Goddard Space Flight Center. So the director there says, Goddard Space Flight Center is go, and said secondary payload. And so, because we were going to impact the moon, and I'm a retired Air Force general, I couldn't resist saying, Ames is go for the first precision bombing run on the moon. And it turned out Tony Colapret, the PI for that mission, later says, what were you trying to do? That's goofy. I said, well, nobody paid any attention to it, although it went viral. And I got in a lot of trouble because some congressman said, okay, he's a retired general. There's a secret alien base on the moon. They're trying to blow it up. And so I got all sorts of emails from people who said, please don't start an interstellar war. My kids want to grow up. So I haven't done much Twitter since then, because I learned my lesson. But the L-Cross mission was a cool one. A little later, we sent another probe back to the moon, a low-cost mission, Laddie, that orbited the moon and actually studied the dust environment. But probably the coolest mission of all was the Kepler mission, which it actually took quite a while to do. And but it got launched while I was there. The Kepler mission is the one that has basically shown through indirect means that probably virtually every star in the galaxy has a planetary system. Maybe a quarter of them have something the size of the Earth in what we call the habitable zone. So those are really cool missions. We did a lot of small satellite missions involved CubeSat. One of the coolest ones was the PhoneSat, where my chief engineer, Pete Klupar, I used to hold up his cell phone and say, this has everything a satellite does. And so finally, some of the young folks there that Creon now works with, Robbie Schingler and Will Marshall and Chris Bosshausen, took him to heart, and they actually, literally in the kind of an abandoned building and later in their garage, showed that you could do CubeSats, and we actually launched 3 of them while I was there, off the ISS. And I remember that the President Obama used to show up at Ames, not to see us, but because he did fundraising in Silicon Valley.
And because he could land his plane there.
Yeah, he could land his plane there. And so of course, I was Peter the greeter, because I was the director. So he bound off the plane, and I tried to talk to him, and you got a couple, I say, well, you guys are doing great. I love NASA. And then he'd go off and do what so I figured that I was like the 4th time he was there. I said, Mr. President, welcome to NASA Ames, where we just launched the world's cheapest satellites. And he stopped. He said, okay, how cheap were they? And I said, well, 2 of them were $4,000. One was $10,000. And without missing a beat, he looked at me and he said, we're giving you guys too much money. and so later, Charlie Bolden asked me, what did the president say to you? I said, oh, he said we're doing a great job here at NASA.
Funny. So, yeah, Kepler was totally amazing. Maybe we get Baruki to come talk to this group and tell us something about that. So, yeah, it's a little bit more then about some of the not, like you mentioned PhoneSat, you kind of implicitly mentioned Planet Labs. There were plenty of other secret and sort of disruptive projects that you nurtured at NASA, Ames. Do you want to mention any more of those before we move on?
Well, we should probably answer everybody's question, but we were trying to do lunar landers, and
Right.
we had a secret building called Area 51, but it ended up not being so secret. And several members of Congress who didn't like Ames doing this stuff managed to stop us. But we did end up doing and the Laddie mission was based on that technology. But the the key thing was to move things forward. Or we started to look at ever smaller satellites, and since then I've looked at chipsats and things that weigh a few grams. So I think it was a pretty cool time.
And the chipset idea, by the way, is that now kind of being instantiated in a much more advanced form in the starshot project, is it not?
Yes, the idea is that you could send probes of that would weigh a few grams with a light sail driven by a huge laser, 100 gigawatt laser, to up to 20% the speed of light. But we worked with actually at the time, a graduate student at Cornell, Zach Manchester, who's now a professor at Carnegie Mellon, and he had students build these little chipsats that, a few grams, and we actually launched them. Although we got in a lot of trouble because, little tiny satellites are hard to track, and various government bureaucrats don't like it. So that's another story, though.
Okay, well, I guess we'll follow on your suggestion to start opening this up to the audience in the remaining 20 minutes. Alston, do you want to manage the questions? I see two.
We have a few. I think Jared was first.
Okay, Jared, do you want to unmute and ask your question, or do you want me to read it?
Oh, sure. My question was, have you ever met Robert Truax? And if you have, what did you think of the big dumb booster project that he was working on until his end?
I did meet Robert Truax, and it was around 2001 to 2003. I was working I was the head of advanced concepts for the Air Force Space and Missile Center, which meant everything they wanted to do, they didn't have any money for. And so I discovered that if you go to DARPA, and I was a brigadier general, and so I ended up being, kind of hanging out at DARPA and counted as an employee, actually. And one of the things that we did was we were very interested in small launch vehicles that were responsive. And so Robert Truax came in with a...
Wait. Sorry to interrupt. Why don't you define responsive? Because some of the audience...
Well, the idea was that what happens if we lost a bunch of satellites? I mean, somebody put a nuclear weapon off in low Earth orbit, and the radiation killed satellites, or that they took them out, or you just lost them. So, one of the ideas is maybe you could launch something that was small and do much of the mission, particularly if it had to do with communications or imaging or, watching troop movements. And so the idea of responsive launch said that okay, you lost big expensive satellites. Maybe in a few days you could launch new ones that would be smaller and do maybe 80 or 90% of the mission. That's called responsive launch. But, at that time, and even today, launches take a long time to get ready. So the idea was to can I have something that's like an ICBM, but didn't cost that much, in a truck or something, and that's got a satellite that you could launch into space. Incidentally, the winner of that competition was SpaceX. So I actually ended up giving Elon Musk his first contract, for the Falcon 1 launch vehicle. And but Robert Truax had another concept, and I did chat with him a little bit about the big dumb booster, which I thought was a great idea. We were interested in a small dumb booster, and there are a number of companies now working on that.
Some of them on this call. Mike,
That's all on the call. Yep.
From Astra.
I just want to add that I have all of his original materials, and his lead engineer is on my team. Just thought you should know.
Cool. No, he was a brilliant guy.
Okay, so let's not. I mean, in a way, I guess Starship isn't so dumb, but it's big. But anyway, let's move on to the next question.
Next one, we have Dario.
Hello. Pete, I have a question regarding these UAP revelations and associated congressional hearings, and I'm just curious about your opinion on it. because it's coming from kind of official sources, U.S. Navy. It's being discussed by high-ranking intelligence people in the U.S. Congress. And considering the nature of your previous work and current work, looking for alien life, etc., what do you think about all this, all these events taking place in the last few years, at least publicly speaking?
Well, let me say, I mean, I was in the military a long time. I never had any clearances on anything that suggested that. I mean, I knew there were some ongoing studies. They were pretty low level. And, my fundamental opinion based on the data, and I don't have any more now than anybody else does, is that there's a real phenomenon there. Obviously people see things, over a drink, I'll tell you what I think they are. It's not aliens. My point is I tend to use Occam's razor on this. Said so you've got a whole bunch of possibilities, and alien visitation is certainly one of them, but it's the most unlikely in my opinion. I think there's a lot of other phenomena that have to do with human technology and human activities that are more likely. Now you can get into an argument, well, these things seem to behave in manners that are out of the realm of current physics. On the other hand, when the first time they did jet propelled aircraft, they were also out of the area. However, that having been said, it's certainly important to do research. I mean, one of my good colleagues and friends, Professor Avi Loeb, I mean, he tends to be more interested in and think it's likely these things are some extraterrestrial visitation. And, he's got a new foundation privately funded called the Galileo Foundation. And we've had a lot of conversations. I'll tell you about one really interesting thing that may give us some information on that. In 2014, a meteorite hit near New Guinea, and some of my former students and colleagues managed to get the data released from the military sensors. And it turned out it confirmed that it's an interstellar object, that its velocity was interstellar, and it hit near New Guinea, and it using the military sensors, we think we can locate where the debris would have fallen within a few kilometers. The data we have suggests it was a metal, which are rare. And of course, Avi thinks that this could possibly be an alien artifact. Again, I think it's unlikely, but I'm involved in the team. We're raising funds now next year to go out, and if we can identify the location accurately enough, you could take a magnet and run it along the bottom of the ocean. It's not terribly deep there; it's 1,000 feet.
Hey,
Sorry. So one of the questions you can do, if you recover these metal fragments and they clearly are some weird alloy, then maybe that does indicate what it is. So those are the kind of scientific things I think we need to do.
So I want to just mention one story which might be attributable to Pete or someone like him on this question, which was relayed to me, which is a certain Pete-like person who may have been Pete said, look, I was high-ranking military. I asked everybody, what's going on? Is there like some secret alien technology or finding that gives credence to the idea that we're being visited? And the reply to him from even higher ranking people was, we wish if we had that, we would have infinite money allocated to our programs to, deal with the defense aspects of another.
I can tell you who that is. That was me. It was General Benny Schriever, which is another one of my mentors, who was kind of the first space general in the Air Force. He built the ICBMs for the U.S. and General Schriever liked to drink scotch, as did I. And so when I was in Washington, I used to station at the Pentagon. I used to get frustrated, and so I'd call up the general and say, "Can I come over and have a scotch with you?" And he said, "Of course." And one night after, I don't know, 3 or 4 scotches, I said, General, you were in charge of the space program as it was in the late 50s. And I said, is there any credence to this? Because there were a lot of these detections or observations during that. And he looked at me for a minute, and I figured, oh my God, he's going to tell me something. And then he leans back and laughs. He says, Warden, you know me. He said, if I'd have had anything, I'd been over there scaring the crap out of Congress so fast. Big scary aliens, we need billions of dollars to counter. But he said, you would too. Now, he never answered the question, but I think that's, the best argument I have, that I don't think they have anything, too dramatic, or they would have gone over there and had billions of dollars, and we wouldn't have been spending all this money on ICBMs and other things.
Right. There's no smoking gun as far as we can tell based on this indirect.
Well, I don't think there is. I mean, the other hand, like I said, it's a fascinating question, and I'm pleased to see that we're seeing a lot of both public and private efforts now trying to get to the bottom of it.
Okay, so we will move on to the next question.
We have Wingott here. I'm not sure if it's still relevant. I followed up with you.
Dennis? Dennis is not speaking. Okay, maybe we move on to the next and come back to Dennis when he's ready.
So far, so good. If you do have another question, just drop it here in the chat. I'm sure Queer News has a treasure trove of questions.
Well, let's see. This is now I'm stumbling. Let me ask Pete if he has you worked on things you can't talk about. Is there anything you can talk about of the nature of the things that you worked on, even if you can't spell out the details? I mean, you were in a missile defense organization and the Air Force, and has any of this stuff like been declassified, or is there anything you could say, or is there any results of these things or follow-ons and consequences that can be mentioned from some of the missions that maybe you can't give us details on?
Well, you're all science fiction fans like I am. The Men in Black came with that little flashy thing, so I don't know any of it anymore.
Oh.
But I think in a general sense, it was clear that in the Cold War and the aftermath, that much of the developments that we base our modern space program, small satellites, new launch vehicles, the electronics revolution, were funded very generously in the Cold War, and we made a lot of progress. I mean, it's not a secret anymore that optical systems of many meters in diameter were developed, for not for looking at stars, but they've been modified since then. And so this technology is being sort of released to the public. I will tell you one that I think I can say about the UAP phenomenon. A good friend of mine a long time ago, she was an astronomer, and right after I was cleared on all these spy satellite stuff, we were having a drink, which is pretty common in these discussions. And, I asked her, I said, well, we have all these cool satellites that look at everything. And has anybody ever looked to see if there are any evidence of UAP? And she smiled and she said, actually, there was an effort. They got permission from the intelligence community to kind of just look through the data. And she said after a few months, they actually found something. And everybody got very excited, got briefed at high levels, the government, that one of the Russian launch complexes, they would see periodically an elongated metallic looking thing that had funny reflectivity, didn't look like anything like an airplane or anything. And she said they got very excited. They said, well, this is evidence of, kind of a UFO thing that's funny shape, and people. In fact, it used to be in France, I think, a UFO is called a cigar volant, a flying cigar, and somebody finally figured out. They said, "Look, these things always show up just before a Russian launch," and so what they figured out was a weather balloon that would launch the upper atmosphere.
That old trope. Huh? Yeah.
Well, but the things they moved because they're different velocities. And the way the system did it was these things were moving while they were taking the image, so they were elongated. And so she said they later watched, and sure enough, they were able to see that. So I think, that it's very interesting stuff. So, clearly the people in these communities, I mean, and I found this in my own career, are very interested in space exploration and space stuff. And they're working very hard to make sure that these technologies are released. So it's, I think that's without getting into, what individual technical accomplishment, but, in my opinion, I think the efforts that we've got or had and still do are very important for our efforts in space.
Well, okay, since we're closing in on the hour, we do have a few more questions. I now know Allison had a question, apparently. So Allison, please.
Well, I mean, I was just going to ask, given your really long track record in the space, are you now more optimistic or more pessimistic that we'll ever get out there, and for your long-term plans? I mean, clearly with your background, it insinuates something, but do you think, we'll make it?
Absolutely. I mean, I think we'll see this decade probably privately funded human settlements on the moon. I think we'll see next decade privately funded Martian settlements. I'm actually involved in a private venture to see if we can use nanosats to go interstellar and maybe even carry life and look for life. I think that the explosion in private sector efforts is going to make my dreams correct. And that what I told people in 1971 when I graduated from Michigan, that in my lifetime, we're going to send probes to the stars. I think it's going to happen.
That's wonderful, Pete. Thank you for that optimistic vision. It's so important that we stay focused on the positive. Is Brad still on? Yeah, Brad, you have to go. So do you have a moment to ask your question and stick around for the answer?
Sure. Yeah, I do have another call. But as far as Breakthrough Listen is concerned, I've been puzzled over the strategy behind it because you're hoping about advanced aliens, and they either want to talk to us, in which case their signals won't be subtle, or they don't want to talk to us, in which case are we really up to ever detecting that? How do you get between those two channels to actually find something?
Well, that's a very interesting question, and that's the essence of the program. There are really three possibilities. Well, first of all, let me say if there's that probably in the next decade or so, we'll be able to detect life-bearing planets, but that doesn't mean there's intelligence in the nearby star systems. But the idea behind technosignatures is that a technological civilization could be seen much further away, so you have a much bigger volume you can search. And of course, the traditional SETI effort was to look for a deliberate signal directed at us. And given the size of the galaxy and the universe and the likelihood that why would they pick radio waves and pick the frequency, because we're not even using those anymore for communications. So we're trying to broaden to look for deliberate signals and laser and other means, and of course that's only one effort. The second one is what's called leakage, and if we consider our civilization, we're not trying to communicate with others, but there's leakage. And to use sort of radio technology, there's high-powered radars used for air traffic tracking and space track.
The more advanced we get, the less we leak, and the more like noise our leakage looks.
Well, and that's true. And so we're looking at new methods, and I'm not saying that that's likely, but I think when you start looking at, we have programs we're trying to figure out how to image exoplanets nearby. And if there is a civilization there that, if they're using any kind of technology, lights or whatever, so that's all leakage. And as we develop more and more capabilities and more frequencies, I think leakage is the more likely effort. The final one, which is fascinating, but it's who knows, is artifacts. And these artifacts could be a civilization that's long gone. I mean, the classic one is the Dyson spheres, capture most of the energy from a star. And there was one of the Kepler stars, there was some conjecture, which I think is pretty well disproven now, that this that every 700 and some days there was a major set of eclipses of the star that indicates something large was there. And so that one of the concepts that Jason Wright from Penn State proposed was it was a old, Dyson sphere that it falls.
Old megastructure. Yeah. So
Megastructure.
that we're closing in on the end.
But I think those are the three things, and of course I'm most interested in detecting any life. But it's certainly important to look at all these.
So last in line, I think is Larry. Do you have a question? Larry and Pete go way back, by the way.
Way back. Yeah, of course. We'll get into that. But no, I was just wondering, Pete, if you're still active in geoengineering and what your interests are, and is there anything new to report?
Well, geoengineering says that one of the ways to address climate change is to adjust the inputs, and it's a highly controversial area. But I've been very interested in what are called solar geoengineering, that you block some of the sunlight out. We've had a series of workshops. There's a lot of interest. The Professor Keith at Harvard has been looking at that. There's a lot of interest in Europe. I mean, I said I live in Luxembourg. The University of Luxembourg has a young professor there, Andreas Hein, who's doing stuff. Airbus is looking at it. So yes, I mean, I'm involved in a low level way. We've talked to the European Investment Bank about other things that can be done. So, but this again is a highly controversial effort. One of the questions is, well, how do you make sure you don't screw it up?
Well, I mean, as you well know, with all the fossil fuels we're burning and the other things we're emitting and building, we're already doing geoengineering, if not deliberately, then inadvertently. So the argument that we shouldn't do it is kind of, in some sense, moot.
That's a whole other about 3-hour discussion.
Yeah.
Bring a bottle of champagne or three.
Yeah.
Well, I might do that. I might be coming over to Europe in the next couple of months, so
Let me know.
might take you up on that.
Okay. Well, I know that some people have said they can stay a bit longer, but we are officially.
I'm going to have to sign off. I got another call here in a few minutes.
All right. Well, thank you, everyone. Thank you, Pete. And thank you, Pete, for enabling my career and so many others. And keep doing what you're doing, and we'll try and keep up.
Sounds great. Thanks for having me.